Okay. So, we are recording. What I'm going to do then is to find the average value, I'm going to take the integral from 0 to 3 of 4 minus x squared, and I'm going to multiply by 1/3, which is the same also as dividing by 3, however you want to think of it. All right. So let's use the first part of the fundamental theorem of calculus. We're going to learn the second part later. Okay. The antiderivative of this is going to be, so I have the 1/3 out front, right? 4x minus x to the third divided by 3. Nice job. We're going to do it from 3 to 0. That equals 1/3 of 4 times 3 minus 3 cubed over 3 minus a big fat 0. Because if I put 0 in for x, right, do you see how both things become 0? Do you want me to let you calculate it on your own? Okay. Did you all get one? Yep. Okay. So what's the relationship between the average value and the mean value theorem? The mean value theorem just basically says if the function is continuous and differentiable, that we can find a value that is equal to the average value. We can find an x value that would produce that. And so if I ask you to find that value of c, we're going to use the average value, but then we're going to solve for x. So here's what I mean. Let's first use the average value. So we're going to do from 1 to 3. I'm going to multiply by what? Good. 1/2 or divide by 2. And I'm going to rewrite this as 9x to the negative third power. Sure, sorry. If I added 1 back onto here, it would have been x to the negative 2. So it's like 9x to the negative 2, but then I divide it by negative 2. Because then that would, negative 2 divided by negative 2 would cancel it, and I'd still be left with a 9x to the negative third.
Can we just do like...
So here are some things you can do with this if you want. You can leave the 9s in here if you want. You can pull, if you want, you can pull the 9/2 out to the front, right?
Yeah.
Okay.
Would it have to be negative 9/2?
Yeah, this is a negative 9/2. All right, I'm going to just leave it in there. Just also remember that the negative 2 power means 1 over the square root, right?
Oh, yeah.
Okay. So, this is like 9/2, negative 9/2, sorry. If I put a 3 in here, that would just be 1 over the square root of 9.
Why square root?
Because I'm dumb. No. Just squared. 1 over 9. There's no square root, because it's not a 1/2. It's a negative 2. apparently I was confused too. All right, minus, let's put a 1 in. So negative 9 halves. And then what would be 1 over the square root of, not square root, sorry. 1 over 1 squared.
Right? Over one.
Yeah, it would just be 1 over 1.
Hold on, we have something.
Yep.
Okay.
Okay. So now let's simplify. Wouldn't the 9s cancel here?
Yep.
So I have negative 1/2 minus a negative 9/2, which would be that, correct? What's negative 1/2 plus 9/2?
8
Which is
1/8.
1/2. Okay, so negative, the negative 1, that would be 1/2 times 4, correct?
Oh,
Which
wait.
is,
So it's 2, never mind.
Mhm.
Yeah, that's why I was
I was still thinking, yeah, okay.
so what this question is asking is find the value of C. Now, C would be on the original function. So I want to find that value of x where it is equal to 2. And so what I do is I take the original function then and set it equal to this average value, and then I'm going to solve.
Wouldn't you have to do plus C?
No. We found a definite integral. We don't have to do plus C.
Oh.
All right, so I'm going to multiply both things through by x cubed. I'm trying to get x alone, remember? Now what should I do? Divide by 2, and then take the third root. Good. So I can just leave it like that. That would be the specific value on the interval where you would have a rectangle that would equal the area under the curve. Great. That's right.
Can I go to that picture?
What's that? You want me to draw a picture of it?
Sure.
Well, she just wants to.
Visual?
That example that you showed where it was
Mhm.
rectangle.
Look at what? I'm gonna just look from 0 to 4, okay. I'm gonna probably just have to go up a little bit. Okay, so there it is. Okay. If I wanted to represent the area, okay, so let's graph a line at the cubed root of 9 over 2. That's 9 divided by 2. Hold on. Divided by 2. That's the same as 9 over 2 to the 1/3 power, right? So I'll just do that. Okay. So, hold on a second. Now, this is cool. See if I can do this. If I go to math, if I go to I equals, again, if I go to calc, and then do 7, okay, and I'm going to do it from 1 to 3. Okay, so there's the area under the curve. Okay. Then if I do, let's go trace, and I'm going to go on the other line now. Okay. I'm going to do this again. Did it do it for me or no? Dang it. It found it, but it didn't visualize it, I don't think. So, do you see the area under the curve, crack?
Mm-hmm.
Okay. What, this rectangle from here to here, the area of that rectangle is equal to the area that is shaded under the curve.
Okay.
And we found, by finding this, we found the big difference. Okay.
Like if I did draw it, then I would look back in my notes, I'd be like, I have no idea what you did.
But what it means is that the average number that this function attains on the interval is 2. I am not going to do area because it seems like you did that correctly on your homework. You understand area, to find area that you're doing an integral. Okay. And then Candace, we talked about breaking it up if they're 2 different functions. Then would you look at the 5-4C notes, please?